the National Research Council. The National Research Council is the bigger public research institution in Italy, with a lot of institutes sparse around the place. ISTI is based in Pisa. I also work for specifically for a couple of research groups. One of them offers virtual research environment to the researchers and to the participants of research projects. And the other group runs Open Air, is one of the networks that promote open science in Europe. Those groups use a lot of services, they run a lot of services, mostly hosted by VMS. A large part of those VMS are running right now on the GAR cloud. We started last year a transition from a traditional XEN plus Upper over Ethernet setup to OpenStack and Ceph. But then something happened. We had to do the same operation for all the institute, not only for our research groups. So we stopped the transition and we started planning another one. The institute runs the core services, email, DNS, etc. on legacy hardware. We had to migrate them, and there are a lot of servers pertaining to different research groups we don't know about. Which are the goals of the transition? Obviously, have more reliability, more efficient use of the existing hardware, because research groups buy hardware to run their projects and then they abandon it. The applications have security vulnerabilities that they are exploited, because when the project ends, nobody maintains those applications anymore. Also, as we are going towards experiment replicability, we have a need to maintain not only a database of research papers, but also the data and the source code used to get the results published on the papers. This means that we will have a big storage needs in future. In this, all those cloud infrastructures are still very hard to set up for a production environment, and Italian research facilities are usually understaffed, with a lot of bureaucracy problems when they need to buy hardware arises. For example, myself and the colleagues that are working with me to this migration are working at the side project. We theoretically are working full time to other stuff. What should be useful in such kind of situations that we guess is very common in the research institutes in Italy. A reference architecture where some specific cases are defined that describe different user scenarios and provide examples of hardware configurations for those scenarios. Also, different setups for the storage side. Some tasks are CPU bounds, others are IO bounds. So these differences we have to take account of. And what should be useful? A specific documentation, not the general purpose one. The OpenStack documentation is huge and is often not so up to date. So often we have to rely on the source code when problems arise. Working example of provisioning a complete infrastructure from scratch, backup practices, and also examples of disaster recoveries procedures. And last, upgrades that with OpenStack especially are not so easy tasks. We are not here to ask all those things, but I'm here to tell you that at the end of our migration, we document and make free all our installation and upgrade processes, our provisioning tool. They are almost Ansible based, and we have a set of Ansible roles that complement the official tools, and document and explain our configuration choices and our architecture and our architecture. We will have we will cover maybe all the OpenStack configuration possibilities, because we are going to have hardware nodes that are only that run only compute, hardware nodes that only run the Ceph services, and other nodes that will be hyper-converged. So compute and storage on the same node. When those infrastructures are stable, so we have research environments. We have our data centers, but we cannot reach a real high availability inside one single data center. So federation, we could explore federation with other research facilities. The guys were asking for them since a long time, but I don't know if someone answered. And also we're sharing our troubleshooting experience and everything that we are going to to build on top of the infrastructure in the future. And that's all.